It saddens me to say that the biggest technological development of our age is about to fail. That means we would miss out on a more sustainable, more productive, and more healthy world. So perhaps the first question is, what is this technology then? Well, it has a few different names used in different situations. Sometimes we call it machine to machine, sometimes we call it Industry 4.0, or usually we call it the Internet of Things. What happens in the Internet of Things is actually quite a basic idea. As soon as we connect the physical to the digital, we try to make the world a little bit smarter. Right? We call this smart homes, smart cars, smart cities. But the basic principle stays the same, connecting the physical to the digital. So if you look at how to make something smarter, it kind of follows the same logic as it would with a human. Right? It starts with sensing something. So what we have is lots and lots of sensors, billions and billions of sensors that we'll be deploying this next decade. And they kind of form the ears and eyes of the Internet of Things. So then all that data is collected and something starts thinking about it, the brain. These are essentially smart algorithms going through heaps and heaps of collected data. And finally there's actuators that actually do something that makes sense with that in the physical world again. And these are generally simple things. It's closing a window automatically. It's turning on the lights when you walk into a room. These are all examples of the Internet of Things. Problem here is that it all starts with sensors and lots of sensors. So a while ago I stumbled upon this, is that if you look at buildings being built today, they can actually be about 20% more sustainable. So we can lower their energy consumption and we can create a climate indoors that would make the people working there around 10% more productive, simply by optimizing the climate in that building. This would be a massive gain if you imagine this completely spread out over the world, this type of technology. Here's my disappointment. It isn't really happening too much. Very simple reason is that you need about 10,000 of these sensors to actually achieve that. And those sensors are cheap. That's not even really the problem. The problem is, are we going to power them? Well, you can do a few things. So the old-fashioned way of doing it is simply saying, well, we'll pull cables everywhere. All right, simply just plug them into a cable and we have power. Well, when you have 10,000 in a building and you need an average of about 30 meters of cable per sensor, that quickly becomes incredibly impractical and very, very expensive to do. Let alone if you now move outside of a building, you're trying to do it in some sort of smart city solution. Generally just not even an option. So then there's a plan B. So, well, we can put a battery in there. Right? Problem here is that they simply do not last very long. So on average, you need to change batteries every 6 to 18 months. And there's a pretty fundamental reason why that is. So sensors are strange little devices because most of the time they're basically not really doing anything. So if you're, for example, you're trying to measure the temperature in the room you are right now. What happens is that you do that maybe once every 5 minutes or 15 minutes. In between, the sensor is sleeping. It's really not doing anything, but it uses this tiny amount of power, about 100,000 times less than your mobile phone would. But then it wakes up. It measures the temperature and it sends a signal to the outside world. This is only for a few milliseconds. It needs, during that time, a power that's roughly maybe 10,000 times more than what it needed before. But this is a massive difference on the battery compared to what it was doing previously. So you get these really high short peaks in power in relation to very long times of low power. The battery cannot handle this. So the electronics are going faster than the chemistry can handle. And in turn, the battery has a strange process in which it's kind of destroying itself. So we're fundamentally limited by this because it doesn't mean matter whether we put a bigger battery in there or we put a more low power sensor, you still have this behavior pattern of long periods of sleep and very short periods of active high power. It's not going to work. So here comes my disappointment. We're about to miss out. This is the biggest technological development of our age, and it's about to fail. But there is hope. There is something we can do about this. And for us, it kind of started with a thought experiment. What would actually solve this? Well, what it would require, I think, is a sensor that would essentially last forever without any maintenance, right? You would simply grab it, put it somewhere, and it works. Or at least, it should at least work longer than the application that you're using it for. So this kind of means that we have to change the paradigm. We have to change from the old plug and play, get it out of the box and it works very easily, to plug and forget. We have to go one step beyond that. Yes, it should be easy to install and to implement, but then you should be worry-free. You don't have to think about it anymore. It simply works. What happens if you do that, as it turns out, you lower the cost of ownership for a sensor solution about 7 times. So the cost drops dramatically. Most of the cost is in maintenance. Most of the cost is a guy going there and needing to change batteries. That's what is making it expensive, and that's why it's not being implemented right now. So in the end, it's a lot easier to implement. And this can be done. This is not science fiction, but we need to approach the problem in a completely new way. What we can do now is we can use the Wi-Fi, 4G, and GSM signals, and other sources as well, to power sensors. So basically, when your phone is asking your Wi-Fi router or maybe telecom tower whether there's a new email, it's sending out a message and it's getting something back. All of those signals are essentially electromagnetic waves. So every signal carries a little bit of an energy load. This is not a lot. So you're never going to power your laptop or mobile phone with it. But we don't need a lot. We only need enough to power this tiny little sensor that sends a message maybe once every couple of minutes. That is almost nothing. So this changes everything. What we've done, we've developed a power module, something that can be embedded in a wide range of devices that uses 4G, GSM, but also other external sources as a power source. So based on that platform, we've built the first plug-and-forget temperature sensor. It's a sensor that when you put it in a building, it will outlast the building it's in. You don't need to go back anymore. Truly plug and forget. So one question that might come to mind is, why now? Because this might sound like it's cutting-edge technology, but in many ways it's probably one of the oldest ideas you've heard in a long time. So Nikola Tesla, the great Nikola Tesla, almost 100 years ago, built this. It's called the Tesla Tower. It's a massive tower that sends out radio waves, and he used it to harvest energy from those signals. So it's just wireless energy. It's a really old idea. There's nothing fancy or scientific about it in that sense. Problem is, it didn't really work back then. The principle worked, but the world wasn't ready for that. The technology wasn't really ready for that. But the world has changed. Today we see this. This is the Amsterdam area. Every dot you see on the map is in fact a telecom tower. So we often have the idea, if I'm making a phone call and I'm standing in Amsterdam or I'm standing in New York, there's like a handful of telecom towers that are handling my call. Reality is that there's thousands and thousands of these towers. So there's this incredible mesh of network signals going in every direction. So whereas Nikola Tesla had one tower, we've made a completely globally covering network of Tesla towers. We just decided to call them telecom towers. They're essentially the same thing. It goes on. We have got these personal Tesla towers that we like to call mobile phones, Wi-Fi routers, or laptops. They're doing precisely the same thing. They're continuously broadcasting signals back and forth, asking, is there a new email for me? The answer is no. You don't get anything. The answer is yes, you get a notification. The communication is still going on regardless of what the answer is to that message. There's this mesh of networks that is ever growing denser and denser and denser, and we're simply using it for communication, even though we can do a lot more with it. So looking at that, specifically, there's actually 3 things that make this pretty hard. And this is why it's not really been done before. First of all, you need to be very, very good at translating those signals into a usable energy. And that's actually a bit harder than it might seem. Secondly, after you've created this energy budget, you now need a sensor system that's extremely low power, because we're only able to get a tiny bit of energy from these signals. So as soon as those 2 budgets match, the device essentially lasts forever. So if you look at sensors and what's going on there, what we see is that this isn't standing still either. This is moving in a rapid pace. If you look at a temperature sensor today, it needs about 10 times less power than it did 10 years ago. So the pace of innovation and making it more efficient is going really, really fast. We don't really notice this because I still have to charge my phone every day. But that's mostly because we're doing more things with it. It's actually becoming much, much more efficient on a very small level. So when you start bundling all these trends, you see a few things. First of all, the density in the network is increasing. There is more and more energy available. Secondly, the sensors themselves require less and less energy. So it's becoming more feasible to actually power them. And finally, the problem is getting really big. We have such an enormous amount of these sensors, and with the Internet of Things, it's kind of exploding. We'll need much, much more, making this a really valuable problem to solve, and a much needed problem to solve. But with that just alone, we're not really there yet. So progress comes in the end from giving meaning to technology. So the idea started with Nikola Tesla, and over the last few decades we've seen a tremendous amount of academic research on this topic. But research alone and technology alone doesn't really help us. We need it to solve problems in our everyday life. That's where value is created. And that's the next step we need to make with this. So one of these things is actually happening. This year in the Netherlands, temperature sensors are being embedded in the roads themselves. So holes are drilled in the asphalt, sensors go into there, and what then happens is that we're actually able to see exactly what the temperature of the road is, meaning that we know when we have to do something against it when it gets slippery, for example. We know when we need to do maintenance, and all sorts of things. And this is something that could not have been done if you need to go back there and close up the highway because you need to change batteries, right? So there's this whole new branch of innovation, of potential becoming available by having a different mindset in which maintenance is no longer a thing, in which plug and forget sensors become the norm. You can go much further with this. If you look at agriculture, you could know on a plant-by-plant basis what the humidity, pH values, temperature of the plant is, optimize your crops and optimize your yields. This has a lot of potential as well. Even when you look further on to healthcare, for example, there's experiments being done with smart patches, a Band-Aid that measures the medicine that's in your blood right now, how your wound is healing. You can think of pacemakers, hearing aids. There's a tremendous amount of technology that could both increase the quality of our life while bringing healthcare costs down. But it's extremely invasive if I need to have a huge battery on my body all the time where you can change it regularly and go back to the doctor. A lot of potential there as well, but we need people with ideas. We need people to move forward on this. So I think innovation becomes very, very valuable as soon as it starts enabling other innovations. As soon as you build one innovation on top of the other, as a society, you start reaping compounded benefits. And this is really my challenge for you. There is this power module available. There is this technology that's at your fingertips. But we need you to start thinking not only what can be done in the existing world, but what can be done tomorrow and the day after tomorrow. And that's the challenge I'd like to leave you with. Thank you.